Hi guys, so I just want to add to our factoring flowchart here, and today we're going to talk about two terms, our difference of perfect squares. So in order to factor a difference of perfect squares, the first thing we need is a list of perfect squares. So I'm just going to write my list of perfect squares right up here, and my perfect squares 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, and so on. And I could get the rest 13 times 13, 14 times 14. So don't forget, the first thing you're always going to do is look for a GCF. Then we figure out what are we talking about, how many terms do we have. Today we're talking about two terms, so we're going to talk about a difference of perfect squares. And your difference of perfect squares means you have a squared minus b squared. There's got to be a minus sign. That's what difference means. And your rule for this is a gives us a plus b times a minus b. So now let's use this rule to go through some problems. So here's my first example, x squared minus 64. Well, do I have a difference? So is there a subtraction sign? Yes, of squares. Well, don't forget my number here. I have this invisible 1 that's there, so I have 1x squared minus 64. Is 1 a perfect square? It's on this list. It is. Is x squared a perfect square? Yes, because my exponent is even. Remember, any even exponent is a perfect square. And is 64 a perfect square? It is. So we're going to figure out our rule here, and I'm going to write what squared gives me 1x squared minus what squared is going to give me 64. Well, what times itself gives me 1, what times itself gives me x squared, x, what times itself gives me 64, 8. So I have x plus 8 times x minus 8. All right, now let's look at the second one. Don't forget, your first step is to always look for a GCF. So do I have a GCF? Yes. My GCF here is 2. But what else do both of these terms have? Well, they both also have at least one n. So I'm taking the n out also. What am I left with after I divide everything by 2n? 18 divided by 2 is 9. I had m squared. I still have m squared. I had an n and I took it out. Do I have anything left in here? No. Minus 2 divided by 2 is 1. N cubed divided by n. So I had 3 n's. I took 1 out. So I have n squared. Now we forget about the 2n and we only worry about our inside. Is 9m squared a perfect square? Is 1n squared a perfect square? Well, both 9 and 1 are on my list, and I have both even exponents, so yes, I've got a difference of squares here. So now what am I filling in? Well, what times itself gives me 9m squared? 3m. What times itself gives me n squared? N, so I have 3m plus n times 3m minus n, and are we done? No, we have to drop down this 2n.